Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 11 from the Specimen paper of the Cambridge 9709 Pure Mathematics paper 1. This question here is about functions, and we're told that the function f is defined for the domain, which is the x values. X is an element of all real numbers, by f of x is x squared plus ax plus b, where a and b are constants. Now, for part A, they've told us what a and b are. They've told us that a is 6 and b is negative 8. So our function, which can be written in this form, this is the same thing, f of x, instead of this f dot colon x bracket, you can say, arrow, you can say f of x equals, so it's going to be x squared plus, now a is equal to 6, so that's going to be plus 6x, and b is negative 8, so minus 8. So this is the function in part A, with the values of a and b as given in the question. Now it's asking us to find the range of the function f. Now, the range of a function is basically all the possible output values it can have. And the domain are all the possible input values that we can have. Now in this particular question, the domain is defined as x is an element of all real numbers. And we can see that there's no restriction placed in the question on the domain. And this function can take any value of x. There'll be no problem. It can give you an output. Any value of x put into here will give you an output. As long as x is a real number, you will always get a real output from this function. But what will be the range of values of that output? That's what we have to find. We've got to find what are the possible values of the output. Now, in order to determine that, what we need to do is we need to think about the shape of this curve. We need to see what type of function it is and how it would look. Now we can see that this is definitely a quadratic function. Okay, it has x squared as its highest power. There's no x in the denominators. This is a quadratic function. So we can see just from the fact that it's in the form ax squared plus bx plus c, it's quadratic. So the first thing we know that it's a quadratic function. Okay, and the second thing we can tell, because the coefficient of x squared is positive, okay, as the coefficient of x squared is positive, is greater than 0, therefore it's going to have this smiley face. It's going to open upwards. So therefore it's going to have a minimum. It's going to have a minimum value below which it never goes. And that's important for us. So we need to know what that minimum is. Okay, because that will be the limit of its range. Its range will be from that minimum and upwards, because it's going to have this type of shape. It's never going to go below this value. So we need to find what the y value is of the minimum is. Now there's different methods we can use to find the minimum. So we need to find the minimum, and the minimum is, another word for it is the vertex. We need to find what the y value of the vertex is. Now there's two methods we could use to find the vertex. Because we have a quadratic equation, okay, in general we could use differentiation to find the minimum value. Okay, in general, if it wasn't a quadratic function, you would use differentiation. But as we have a quadratic equation, we could also use what's called completing the square. So we can rewrite this in complete the square form. So we have x squared plus 6x minus 8, x squared plus 6x minus 8. To complete the square, I'm going to write a square bracket, and I'm going to write x. I'm going to write plus because there's a plus here. That'll take half of the coefficient of 6, which is 3. And then take away the square of that number, which is 9, and then I've got my minus 8 after it. This part here is exactly the same as this. If I was to expand this, I'll get x squared plus 6x plus 9, but then taking away the 9 will leave us with x squared plus 6x, and then there's a minus 8 at the end, so you end up with saying f of x is equal to x plus 3 squared minus 17. So the vertex of this function is given by the y value being minus 17, which is what we're going to use in our answer. And just for information's sake, the x value of the vertex will be whatever value of x makes this bracket 0, okay, which is going to be negative 3. Okay, because this function will reach its smallest value when this bracket becomes 0, because you've got minus 17 plus something. This will always be positive. X plus 3 all squared, you will never get anything negative from this, because you're squaring whatever value comes in here. But the lowest it can be is 0. This particular bracket, when you square it, can be 0. And that's when x equals minus 3. So when x equals minus 3, this is 0, and what you're left with is f of x equals minus 17. So that's the lowest value, and that's the x value at which it occurs. Now in this case, all we need to worry about is the y value of the vertex, because that's the lowest value that f will be. So we can say the range of f, okay, we can say the range of this function f is going to be y is greater than or equal to negative 17. It can reach negative 17, but it can never go below it. Okay, if you were to make a sketch of this, you have minus 3, minus 17. It's going to be somewhere over here that it turns. Minus 17 is going to go something like this and continue upwards. As we can see, it's going to cross at minus 8. So it'll be something like this, we could say. Make it a bit more to scale. It's going to go like this. So it's going to cross at minus 8 here, and that's a minus 17. That's where it's going to be its vertex. Okay, we don't really need to know where it crosses the x-axis. I'm just illustrating you that that's what the graph looks. So the range is always the y values that something can take. That's why you write y. Or you can write, if you want, f of x is greater than or equal to negative 17. That's the range of this function. Both of these can be written in form. Don't write x for the range. Okay, you don't write x for the range. Y or f of x. So that's the range. The range is the smallest value, or the range is all the values that can be generated in the output of this function. And you can have anything from minus 17 up to infinity. Okay, but you will never ever be able to get anything less than negative 17 by putting any value of x into this function, because that's the lowest it ever goes. That's what that means by the range. So knowing how to picture what the function looks like is very important when we're dealing with this topic of functions and ranges of functions. Right, now for part B, it says it's given that instead that a equals 5 and the roots of the equation f of x equals 0 are k and minus 2k. So we know now that a equals 5 and the roots of the function f of x equals 0 and k are minus 2k. So let's put that information in here. So a equals 5. So we can say that f of x is now x squared plus 5x plus b. All right. So we have to find what b is, and we have further information that the roots of the equation f of x equals 0. So when f of x equals 0, the roots means that x equals k and x equals minus 2k. All right, when f of x equals 0. So what we can do here is we can kind of work backwards from this. We can say, okay, that means x minus k equals 0 and x plus 2k equals 0. Okay, would have been, for example, the step before this, if you were solving the equation, finding the roots. Okay, finding the roots, you have to factorize, and then you say either one factor is 0, the other factor is 0. So the step before this would have been x minus k times x plus 2k equals 0. That would be in the step before this. Okay, so our equation will look something like this. Now we know that the value of the coefficient of x squared is 1. Okay, so I don't have to put anything out here to show what the coefficient of this would be. It wasn't divided by anything because the coefficient of x squared is equal to 1, as we can see in the original equation. So what we can do here is we can say that therefore f of x, I'll put that here, f of x is equal to x minus k times x plus 2k. So now what I can do is I can compare these two. They have to be exactly the same. And then I can deduce the value of k and the value of b. So what I'm going to do is I'm going to expand this bracket. And this will be x squared. Then I have to multiply this by this. That's 2kx minus kx. So that's going to be plus kx. And then minus k times plus 2 times plus 2k. That's minus 2k squared. So now what I can say is the value of k is equal to 5. Okay, because it's the same as this. K is equal to 5. All right. And we can also say that b is equal to minus 2 times k squared. So that's equal to minus 2 times 5 squared, which is minus 50. So we got k equals 5, and we have b equals negative 50. And there's the answer to part B of this question. Okay, there's the answer to part B. All right, so that's how we deal with this. So it's basically, if you know that these are the roots of the equation, x, that means when fx equals 0, x equals k, and x equals minus 2. The roots of an equation are basically the values of x that make that equation 0. So it's like the solutions to this equation. So now if I think backwards, as I said, you know, if x equals k, then before that we would have x minus k equals 0. That's what led us to this. So kind of we're working backwards. Same with this. X equals minus 2k, that means x plus 2k equals 0. That means x minus k times x plus 2k equals 0 was the step before that. You know, you factorize and then you find that these two factors equals 0. So this is the original equation. We don't have to put any constant in front of it because it's x squared. That's 1x squared as well, so that's fine. So right, magnitude, we can just expand that and compare to the original equation. So we say the coefficient of x is k. Okay, so the coefficient of x is 5, so k equals 5, and the constant is equal to minus 2k squared, so the constant is equal to minus 2 times 5 squared. So that's how we deal with part B. Now I think there's a part C. Let's have a look. Yes, there is. It says show that the equation f of x plus a equals 0 has no real roots. Show that if the equation f of x plus a equals a has no real roots, then a squared is less than 4 times b minus a. Okay, so now what I'm going to do is I'm going to, first of all, write down what fx plus a is. Now, what does this mean? Now, if I said to you, find f of f2, what you would do is you would replace the x with 2. That's what we do, substitution. So fx plus a simply means replace the x in the equation with x plus a. So instead of x, I'll write x plus a squared plus a times, instead of x, I'm going to write x plus a again. I got plus b. And it says fx plus a is equal to a. So it means when I've replaced the x with x plus a, the whole thing will just equal a. So I have x plus a squared plus a times x plus a plus b equals a. Right? So I'm going to expand this and simplify it. Okay, so I have x squared plus, if you expand this, you have 2ax because you multiply these together and double it, plus the square of this, which is a squared, plus you have ax, again another a squared, plus b equals a. So I've got x squared. I've got 2ax plus ax. That's plus 3ax. And then I've got plus a squared, which is 2a squared. And I've got plus b minus a equals 0. Okay, plus b minus a equals 0. So now I have got this equation in a form like, you know, a quadratic form, ax squared plus bx plus c. Now, we want to show that when this has no real roots, okay, so there's no real roots when the discriminant, so no real roots when the discriminant is less than 0. And the discriminant is b squared minus 4ac. Now, what you got to be careful of is the b and the a in this formula are not the same as the b and the a in this equation here. Okay, b squared minus 4ac has to be less than 0. And that refers to when you got ax squared plus bx plus c equals 0. When you're solving this equation and b squared minus 4ac is less than 0, then it has no real roots. Okay, so what we're going to do, we see that in our case, our b, okay, is basically 3a. Our a is equal to 1x squared, and our c is equal to 2a squared plus b minus a. Right? So when b squared minus 4ac is less than 0, you're going to have 3a squared, that's b squared, minus 4 times a, which is 1 times 2a squared plus b minus a. And we know that is less than 0. And we have to show that this is true. So let's see if this leads to the same as that. So this is going to give us 9a squared minus 4 times 2a squared. Let me just do that in one step. So minus 4 times 2a squared is 8a squared. Minus 4 times b is plus 4b. And minus 4 times minus a is plus 4a is less than 0. Now let's see how it has to look. A squared is less than, so it's like you made the a squared the subject. Okay, a squared is less than 4 times b minus a. Okay, so we got here, all right, 9a squared minus 8a squared is a squared. Okay, and now we're going to subtract this from both sides. Is less than minus 4 times b minus 4 times a. So I've subtracted these two. I subtracted that from both sides. So a squared is less than minus 4 times b minus a. And is that what we had to show? Plus 4 times. What did I do? Minus 4. Okay, so now we got 3a all squared, which is 9a squared, minus, so we have minus 4 times 2a squared, which is minus 8a squared, and we have minus 4 times plus b, which is minus 4b, and we're going to have minus 4 times minus a, which is plus 4a, is less than 0. So we have 9a squared minus 8a squared is a squared, minus 4b plus 4a is less than 0. And how do we have to write it in this form? So we're going to leave the a squared on its own. So we're going to have a squared is less than, if we add 4b to both sides and we take away 4a from both sides, and then finally we just take out that 4 as common in these two terms, and we've got exactly what we're looking for. A squared is less than 4 times b minus a. Okay, so we can see that this is what we had to show as required. So that is the answer to part C of this question. Is there a part D? No, there's not. Okay, so that answers question number 11 from this worksheet. So we have to understand that when there's no real roots to a quadratic equation, the discriminant is less than 0. The discriminant, as a little side point, the discriminant is the part of the quadratic equation, okay, which is under the square root. So x equals, if you have an equation ax squared plus bx plus c equals 0, then the solution to this using the formula is minus b plus or minus the square root of b squared minus 4ac all over 2a, which is given to us in the formula book in the Cambridge, right? But the important part of this equation in this particular part of the question here is this b squared minus 4ac. If this thing here is negative, then this will be undefined and there will be no solutions because it'll have the square root of a negative number. That's why when the discriminant, which is the b squared minus 4ac, now remember this is a, this is b, and this is c. It's like this is, quadratic. 1 is your a, your b is a coefficient of x, and your c is a constant, which is all of this. Okay, so that's where you have to be a bit clever about it, and don't get confused between the b and the a in the formula and the b and the a in the question. All right, have to understand what this means. This means the coefficient of x. This means a constant. That's a coefficient of x. That's a constant, and 1 is the coefficient of x squared. Okay, and if b squared minus 4ac was equal to 0, then you'll end up with x equals minus b over 2a plus or minus 0. So there'll only be one solution. There'll be one. It's called a repeated root. And if this is a positive value, you have minus b plus or minus something over 2a. So you have minus b plus something over 2a and minus b minus something over 2a. So you'll end up with two distinct solutions. Okay, so if the question said, show that if equation f of x equals a has two distinct solutions, then we would start off by writing b squared minus 4ac is greater than 0. If it said has real roots, means you can have two solutions or one solution, I'd write b squared minus 4ac is greater than or equal to 0. If it says that has repeated roots, then we'll say b squared minus 4ac is equal to 0. So depending on what this phrase is, we know what to do with the b squared minus 4ac. Okay, so that's a little bit of a summary of that idea of discriminants and how we apply that to this question. That completes this question, which is question number 11 from the Pure Mathematics P1 Specimen paper from Cambridge, 9709. Other questions from this particular paper can be found in the playlist that will appear in this link over here. The link over here at the end of the video will take you to the topic of quadratics and also functions. Okay, so I'll have quadratics here and I'll have functions there. Okay, because it's related to both of those topics. And you'll also have a link here that will take you to a video that explains how to use my channel effectively. Thank you for watching and see you soon.